Okay, so here's something a little bit different. So a bit of a recap. This is my Jaguar AJ30 with an air conditioning pump on one side and an alternator on the other side because it's from a Jaguar S-Type. But there is a little bit of a shortage of space, let's say, between the two extremes of the alternator and the air conditioning pump, which I want to retain. So it'd be quite nice to get a smaller alternator, and also one that fits, because this one requires a mounting on the sump, which is not there because I've changed the sump. Anyway, so one of the questions that arises is how big the alternator I need. How big actually is it? This is 120 amps, so it's fairly chunky, as you can see. And it'd be quite nice to get a smaller one. But the question is, how big does the alternator need to be in terms of its output? So what am I going to do now is to do some experiments. And I'm doing the experiments on a different vehicle. So here is my son's Dutton Phaeton, which is equipped with a Ford Zetec engine. And what I'm wanting to do is to measure the amount of electrical power that is taken from the alternator just to run the engine. So that's the fuel pump, the ignition, the injectors, the ECU, and so on. And so I'm going to see if I can measure the current demand from the engine itself. And that data seems to be relatively hard to come across, to be honest. Headlamps, wipers, fans and things like that are all quite easy. But the running of an engine? So here is the engine, the Ford Zetec engine. It's mated to a 5-speed gearbox from a Ford Sierra, in line as you see. I think this one came from a Ford Focus actually, but it is using the standard Ford ECU, and we've done some jiggery pokery to get around the immobiliser side. I won't go into that right now, but anyway, suffice to say it's been up and running for some years actually. But right now, before I can investigate the experimental side of how much current the thing is actually drawing, there is actually a slight problem. And the problem appears to be the battery is discharging. Now I will emphasise again, this car has been running absolutely fine for a few years, and this problem has arisen only very, very recently. So we need to find out what that is due to. The battery has been rather discharged. Okay, so I've put the battery on charge, and bearing in mind that it was driven last weekend, and then a battery isolator switch was used to disconnect it. So it was running last weekend and hasn't been used since. This is looking rather like the battery is indeed not very charged. So I'll give that a little while and see what happens then. Well, that's interesting. Went, but not very quickly. But I don't know whether 14 from this micro alternator. Now I'm going to put the headlamps on and see how much that is. So headlamps are on, and that's reading 11.99. So that suggests it's not really charging at either speed. Try it again. So once again I'm trying to see how much current is taken by the engine, and luckily I have, in fact I'd forgotten done this, fused the alternator connection with this large fuse, which means I can insert, albeit a standard multimeter, so it'll only take up to 10 amps, I can actually measure how much current is taken. So let's see. So the trick here is going to be avoiding blowing the fuse in the multimeter while starting the engine. So I think what I'm going to do is I'll disconnect the meter from the circuit. I'll start the engine just on the battery, and then I'll plug it in, and then I'll disconnect the battery. Right, here I go. So I've got the engine running. The battery is connected, and now I'm going to disconnect the battery with the engine running. Just trying to think if that switching this thing off is enough. Might be actually. And there we are. 11.8. This is just the engine and ancillaries, nothing else switched on. And with the battery connected, it drops to about half that. Ignore the fact it says minus, that's just because it's on the wrong way round. Okay. Not sure what that proves. The alternator hasn't got enough output for the engine, perhaps. But anyway, there it was at idle, 11 point something amps. Running again, it's taking less. Oh, that's with the battery connected. So that's purely the alternator running the engine systems now. And as I rev it, it dies. Interesting. Well, I think that's a double test, actually, because there may be something up with this alternator. It's looking increasingly like that, but nevertheless, it's a valid test because 11 point something amps. At idle speed. That's the fuel pump, the injectors, the ignition, the ECU, everything at the same time. Feels about right to me. The fact that it doesn't seem to continue as the engine revs up probably means that the load increases as it revs up. We'll have to see about that, but I'll need to fix my alternator problem. But what is for sure is that the alternator at idle on this 15 alternator idle on this 4-cylinder engine is delivering about 11.5 amps. There it is. But one thing I hadn't remembered to consider, of course, is the fact that the meter is only rated up to 10 amps in the first place. That's right at the top of its range. How accurate is it? Hard to say really. But it wouldn't be surprising if it became a problem as the load increased. I have just tested it with, in fact I'll do this now, with the meter disconnected, still the battery disconnected, rev and it'll falter. Oh, actually I was wrong, it didn't falter. Or maybe it did. Yeah, a little bit of uncertainty there. So I'm having another go at measuring the current load from this Zetec engine, including things like the ignition system, the injectors, the ECU, and the fuel pump. And but rather than interfering, as it were, with the connection to the alternator, I've realised you can actually get a pretty good connection at the fuse box. And here we have a couple of typical crimp-on connectors crimped onto the end of the meter probes, and they insert very well. They insert very well into these blade fuses sockets. So let's see what happens when you switch the system on. First, find the key. Right, instead of doing it inside the car, I've actually decided to put the ignition key in and do everything from the battery switch. So here we have the ECU switching on as I switch the battery key on. Now that's not very much. And now I'll see if I can start it, which I'll have to do from inside the car. Oops. So there we have it. The around here where it's a bit quieter, the load from the ECU, which is the ECU load itself, including the ignition and the injectors, is around about 2 amps, and the rest of the load that is required to run the engine is coming from the fuel pump. Just doing a quick retest. I thought I'd run it with a bit of revs on the engine. There we go, it did actually go up quite a lot. It's gone back down to a similar level before. So what did that reach? Nearly 10 amps, 8 amps was it? And about 2 to 3 amps at idle. Yeah, so more load from more engine speed, which is kind of what you'd expect really. I'll now do the same with the fuel pump. So I'm just inserting the meter into the fuses for the fuel pump, and do the same again. So we're on about 11 amps idle. Interesting, that read nearly 20 amps. So I'll do the maths on that. 20 amps plus 10 amps. Yeah, that's quite a lot really, but it does respond to engine running, and that is